Okay, so good morning to everyone. So in today's topic, we will discuss about the NP hard and NP complete problem. Now, whatever we have said, that whatever algorithms we till now we have seen, this NP hard and NP complete, this is not the algorithm. This is not the algorithm. Now, whatever the algorithm we have seen, this is what this is a research. We can say this is the research based thing. This is the research based thing that in PhD, if you see, the work is going on over it. Now, based on what that, if we differentiate that, we have seen some algorithms which it has taken polynomial time, and some algorithms we have seen that takes the exponential time. Now, the algorithms which we have seen, that linear search, this linear search algorithm takes order of n. This binary search algorithm takes log n time. This insertion sort take n square. This merge sort take n log n. And the matrix multiplication, this take n cube. So if we see, all these algorithms are taking the polynomial time. These algorithms are taking the polynomial time. Whereas 0-1 knapsack problem, it takes 2 to the power n, that means exponential time. Now here, the exponential time taken algorithms which we have used here, it can be 2 to the power n or anything, some constant to the power n or some n to the power n, like this. So that's why we called it as the exponential time taken algorithm. That means 0-1 knapsack algorithm, traveling salesman algorithm, traveling salesperson algorithm, sum of subsets, then graph coloring, then Hamiltonian cycle. All of these are taking the exponential time taken algorithm. Now, this topic is based on the research, and till now, we didn't find the solution till now. The research is going on. And if you done that, or if you try it, then it will be very much helpful. But till now, there is no such thing we have discovered till now. Now, what is our motto? Our motto in this is that the algorithms that are taking the exponential time, that is 0-1 knapsack, traveling salesman problem, sum of subsets, this algorithms taking the exponential time. We are doing the research that is this algorithm can be solved in the polynomial time? Can be solved in the polynomial time? The research is going on over that. Or we can say that here binary search is the fastest algorithm. Binary search is fastest algorithm for searching that takes the log n time. Can we convert, or can we search of any algorithm? Can we search any algorithm which is faster than this one? That means any algorithm that can take order of one time. Can we find? Or all the algorithms that is taking the exponential time, can we solve this problem in the polynomial time? This is what about the research is going on. Now, we want to solve the exponential time taken algorithm in the polynomial time, and the research is going on for this. Research of NP hard and NP complete. Now for this, the research, NP hard and NP complete framework is used. This framework is used for the research is going on. Now, there is two ways. There is two ways we can say that we will move our research. And this way the research is going on. Now, what is this? That means there are two types. We are saying that when we are unable to solve any problem, that means when we are unable to solve any problem, this topic you may find difficult, but I am trying to you to say this because this is the research based topic. It is not any algorithm. So carefully, you please be careful. So that is what This is the based on two topics. Now, what is this? It is saying that always remember that in this problem, what we have to find, that there is the exponential time taken algorithms present, and we want that these algorithms can be solved in the polynomial time. That means, can we solve 0 1 knapsack problem in the polynomial time? Or can we solve the traveling salesman problem into the polynomial time? Can we solve the problem of sum of subsets into the polynomial time? Can we solve the problem graph coloring in the polynomial time? And can we solve the problem of Hamiltonian cycle in polynomial time? This is the thing. Now, if we want to solve each and every exponential time taken algorithm used in polynomial time, then it will take much more time. It will take much more time. So that if we can say, if we can find any relation, if we can find any relation between this, the algorithms that is present, if we find any relation between this, then we can choose any of the algorithm and can solve it using the polynomial time, and say for that, that if it is going for, if this can be solved using the polynomial time, then the other problems can also be solved using the polynomial time. That means, if between 0 1 knapsack, traveling salesman problem, sum of subsets, graph coloring, and Hamiltonian cycle, if these five algorithms, between these five algorithms, if we make some relation, if we can able to show some relation, then if we pick just one algorithm and it's solved using the polynomial time, then we can say that all the algorithms we can solve using this exponential time taken algorithm. All other problems can be solved in the polynomial time. But that for doing also, we have to find some relation. Okay. So based on two things that is going on, that whenever we can say, whenever we are unable to solve the problem, let's say whenever we are unable to solve the problem or get the solution to the problem, that polynomial time algorithm for them at least do the work such that try to show the similarities between them. That is what I have said, that if we didn't able to find the result or get the solution, that to solve it the algorithm using in the polynomial time, then at least do the work, we can do at least work such that we can show the similarities between them. That means if we didn't able to find, till now we didn't able to find it, because the research is going on over that. Till now we didn't able to find that, but we are trying to show the similarities, because if the similarities between them we can show, that means between the similarities 0 1 knapsack, traveling salesman problem, sum of the subsets, graph coloring, and Hamiltonian cycle, if these algorithms, between this algorithm we can able to show some similarities, then if one problem is solved, if one problem is solved between them, the other problems should also be solved. Then we will not be doing research work individually. We will not be able to not do research work individually on each and every problem. Now let us combine them all collectively. That means let us combine them all collectively and put some effort that if one problem is solved, if one problem will solve, then for that we have to show the relationship between them. So this is the thing, that if we able to show some relation between them and put the collective effort and put the effort collectively, then if one problem is solved, that means if we combine all of this and put some effort, that means such that if let's say 0 1 knapsack problem is solved, then we can say if we can make the relationship with other algorithms that is present in the exponential time, then one problem of the exponential time or one algorithm of the exponential time taken, if we solve, and if there is relationship between them, all the algorithms, then we can say if this can be solved in this way, others also can be solved in this way. This is the thing about the research. Okay, समझ में आ रहा है? It is clear?
Yes,
It
sir.
is clear to everyone till now? Okay. Be careful. This is not related to algorithm topic. This is the research based topic. So be careful when you will do, be careful of it. Okay. Now the next, and this is based on this, the research is going on. And another one, first I have said that two, based on two things, this is going on. So the first thing is that we have, if we put collectively, all of this we combine collectively and put some effort such that if one algorithm or one problem can be solved, and if there is the relationship present, we can say that this problem is solved in this way, then all other problems can be solved in that way also. And the next thing is, when we are unable to write algorithms, let's say when we are unable to write algorithms for them, that is the deterministic. I will explain what is the deterministic. But till now, only remember that when we are unable to write algorithms for them, that is the deterministic. Why do not we write non-deterministic algorithm? That means if we are unable to write polynomial time deterministic algorithm, if we are unable to write polynomial time deterministic algorithm, then we can write the polynomial time non-deterministic algorithm. Okay. So what is deterministic and what is non-deterministic, we will discuss now. Now, the algorithms we write usually are deterministic. Now that means what? The algorithms basically we write is the deterministic. That means each and every statement, how it works, we know it clearly. That means each and every statement that is present on the algorithm, that if you write the algorithm, then in that algorithm, whatever you have written or whatever the statements, each and every statement you write, you know how it works. We write the statements and we sure how they work. So we write that statements into the algorithm, that what we know. That means the working, we know that if we write this statement, that means this statement will work like this. We know that. And that statement we write in the algorithm. It is the way. So that is the deterministic. That whatever we already know that if we want to write an algorithm, in this algorithm we will put the statements, and that statements, what this statement works or how the statement works, we know about it. How it works, we know about it clearly. And that's why we are writing this into our algorithm. That is the deterministic. So that is why it is deterministic. So we can write non-deterministic algorithm also. That means what? Non-deterministic means what? We do not know how they are working. So if we do not know the statement that are how they are working, we are writing the statement, but we do not know how they are working. So how we can able to write the algorithm which we do not know? How we can write the algorithm? Let's say an example, we want to write 0-1 knapsack problem in the polynomial time algorithm. Now the 0-1 knapsack, we have seen that 0-1 knapsack problem take exponential time. Let's say we want to write this 0-1 knapsack problem in polynomial time taken algorithm. Then we must know all of the statements, but there may be some of the statements may not be figuring out how to make them polynomial. Now in the statements, when we will write, we must know that how the statement, but some of the statements that may not be figured out how to make them polynomial, because the algorithms that is present already, the algorithm 01 knapsack problem which is present, it is written in the exponential time taken algorithm. Now we want to write this 01 knapsack problem in the polynomial time taken algorithm, using in the polynomial time taken algorithm. Then what we will do? We know all the statement or most of the statements, because most of the statements we already know there, but some of the statements that may not be figuring out how to make them polynomial. Now some of the statements between them happen that we do not know how to make them polynomial. Then what we should do? We will left blank on that statement, or we can say that is the non-deterministic. So when we will able to know how it should be filled, then we will fill the statement. That means, let's say we are writing the algorithm for the 01 knapsack in the polynomial time. So most of the statements we already know, but some statements for polynomial time, what it will be, we do not know. Then what I will do? I will left blank on that statement. I will left blank on that statement. That, and also most of the statement must be deterministic, because most of the statements we already know, but some statements we not know, and how they are working we also didn't know that. So we will do what? We will left blank there and say this is non-deterministic. That means we didn't know how that can be solved. So when we will able to know how it should be filled, then we will fill the statement. That means we left blank, whatever we have left blank in the algorithm, that is the non-deterministic. We didn't know how it can be done. So if we know, if we able to know, then we will fill up the blank. And also most of the statements, mainly most of the statements are deterministic, but some statements are non-deterministic. So for that, we will write a non-deterministic algorithm. And the thing which, if we want to write an algorithm, and in that algorithm, let's say some code we have written, let's say in that algorithm, some statements we have written, some statements and why they are using, or what they are used for the purpose we know. That is the deterministic, because we already know about that. But some statements we have written, and till now that we didn't know about it, and how these statements are working we didn't able to know about it till now. So what we will do? We will left blank there, and we will preserve this algorithm. Now why we will preserve this algorithm? Now if we didn't preserve this algorithm, then in the future, let's say you have put some non-deterministic statement. It may happen that in the future, any other person who are doing the research can find that statement deterministic. That means he or she can able to say that these statements, how these statements work, which we didn't able to say that how this statement work. He or she can say, may say that this statement working like this, or these statements can working like this. He or she can say. So that means if we didn't preserve the algorithm, this non-deterministic algorithm, then in the future, somebody else is working on that same problem and make that non-deterministic part as the deterministic. It may happen. So this is the concept of the deterministic. So deterministic means what? Deterministic means that if we write any statements, deterministic means in the algorithm we write statements and we know that how that statements work. This is the deterministic. But non-deterministic is what? Non-deterministic means we write the statements, but we didn't know how they are working. So this is the non-deterministic. Now, if let's say we want to solve the problem Now the problem is basically present in the exponential time, and let's say we are writing it into the polynomial time. Like example we have given that 0, 1 knapsack problem that is present in the exponential time, and we write it into the polynomial time algorithm. Now whenever we want to write it into the polynomial time algorithm, then some deterministic statements will be present, some non-deterministic statements will also be present, because some statements may be matched. This between them, some statements may be matched, but some statements will be new. This may happen that some statements are new because it is in the polynomial time, then some statements can be new for you. So what you will do, you will preserve that statement. If you are unable to solve that, if you are unable to solve this, then preserve the algorithm so that future any researcher in future can solve the non-deterministic part which you have mentioned in your algorithm, and you are not able to solve that, then in the future case or in the future some researcher can do research on that particular non-deterministic part and make them deterministic. It may happen. This is the concept. This is how the working is going on. Okay. So example, let's say if an example we want for a searching algorithm, that whatever we have said, that till now our fastest algorithm is we have found that binary search that takes a log n time. But we are going on that, we are searching any algorithm that is taking order of one time. Order of one means this is much faster. So the searching or the research is going on over that. So for this order of one time, we write an non-deterministic algorithm. Now, what is this? So first, let's say this algorithm is written, that algorithm we have named algorithm in search. And this in search algorithm is taking three inputs as a parameter, three arguments as a parameter. Now, what is this? Is the name of the array. This is the length of the array. So that means an. N is the length of the array and A is the name of the array. And key is the key element that which we are searching in the array, that this is present or not. After that, inside the algorithm, we have written j equal to choice. We have written j equal to choice. Now, how this choice will work? How this choice will work? This is the non-deterministic statement. Now, how this choice will work? The choice will know that the key element that is present at the jth position index, choice will know that the key element that is present at the jth index. That's why it is called, that's why it is non-deterministic, because j will find what? J will know, j will know that the key element that is present, the key element which is present at the jth position, at the jth index, choice will know directly. So that is why it is said that the choice will know that the key element that is present at the jth index, what it is, deterministic, non-deterministic. That is why it is non-deterministic. And now here we have written if k equal to aj, that means the key element. Is the key element find between the aj, key element is present into the array j. That means if the key element is present in the array, then we can write j. And after that, we have written success. Now, this success is also a non-deterministic because we didn't able to define the statements, this success. And if the key element is not found in the array, then we write 0 and write the failure. So this failure is also, if we see, this failure is also a non-deterministic statement. Now, why this a non-deterministic statement? Because any particular information we cannot able to get from this statement, because we are writing j equal to choice. That means what choice will do? Choice will find the key element that is present at the jth position. Choice will find the key element which is found at the jth position. Now, how this choice will found? We didn't know that. How this choice will found? So we have written the statement that j equal to choice. That means choice will find the key element in the jth position. But how this statement is working, we didn't know that. That's why we have said that this is the non-deterministic statement. Then after, if the key element is found in the array, we will write j. Okay, that is not problem. We will write j. But after that, it will be success. Now, what is the definition of this success? What is saying this success? We didn't know that. What is the definition of this success? So that is why it is also a non-deterministic statement. And if it is not found, the key element is not found in the array, the key element is not found in the array, we will write, okay, that is not found, and we will write failure. But what is the purpose of this failure? What is the purpose of this failure function? We didn't know that, but we have written it into our algorithm. That's why this is the non-deterministic. Now, we are assuming that in future, it may happen that any researcher, can research over this and find this non-deterministic statement and convert it into the deterministic part, that this researcher can able to find out what and how this is working. The researcher can able to find out that. This is the concept of it. Now, what it means if we say, let's taking an example, let's say if we are this will, now what it will be, let's say we are taking an array. Let's say we are taking an array. This is the array we are taking. Let's say in this array, total 5 elements are present. Let's say 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. So we will give index number. Let's say we are starting with the index number 1. Let's say we are starting the index number from 1. And this is the array. This is the array. So in this array, the elements that is present 10, 8, 9, 4, 2. And the key element is the key element which we want to find, that is 9. We want to find that is 9. The key element that we want to find, that is 9. Now, if the not, we are saying that without any using logic, we already know that in binary search, we will search like that. For linear search, how the searching will go on, and after that, after the searching, we'll find the key element that is present in the array or not. But here, we are trying that if without any logic, without using any logic, it will say, we are saying that without using any logic, it will say that the key element is present at index 4. That means this key element, this 9, is present at let's say this is 9. Okay, this is 6. Okay, so directly without any using any logic, we will say that the key element is present at the 4th index. Till now, is it possible? Till now, we have not seen such an algorithm. Till now, whatever algorithms we have seen for binary search, linear search, any algorithms we have seen, it is not like that, that directly this algorithm will say that in this position, the value is present. We didn't see about that. But we are trying to develop that directly this algorithm will state that the key element is present in the 4th index without using any logic. Can it be possible? It is going on. The research is going on over that. And till today, we didn't know how this can happen. Till didn't know because there is any logic present. No logic is present till now that how this can be happened. But let's hope in the future it may happen that this can be found without any using logic. We will able to know that the key element is present or not. This we can may able to find out. So today we can say this is the magic to us, because this is look like a magic, because if we didn't find any solution till now, but if we are seeing the graph in the magic also, the magician do what? The magician, if we didn't know the trick, then we say that the magic is great. But when we know about the trick, when we will able to know about the trick, then we will say, okay, we have know about that. But till now, from in this example, we can say till now, this is the magic to us, because no such algorithms we able to find till now that which directly returns the key element, saying that the key element is present in the final index or not. But today, what is a magic? It may happen that later on any researcher can find this. You may be also the researcher, that if you work on this, and if you any of you person do the PhD, then you will let's say in the PhD on the research part, if you work on this, then you can also able to find out that it may happen. But in that time the techniques will arise, and we will able to know in that time it will be not magic, because we will able to know the technique in that time. So now it is non-deterministic to us, but in the future any researcher do research and find the trick of that magic, then in that time it will be deterministic, or we can say that technique we will find. So this is the concept. That's why I have said all these statements which I've said, because if I not state the statements, you will not able to understand that. This is the thing. This is the main thing, that only based on two things, this is gone. This is over the two things, that we want to find more efficient. Main thing is we want to find more efficient algorithm. For if we can solve the exponential time taken algorithms to in the polynomial time taken algorithm, or we can say the best case, or we can say if we find any searching algorithm, if we find any searching algorithm that takes order of one time, this is the thing. Clear to everyone? ये टॉपिक थोड़ा अलग है, इसीलिए किसी का समझ में आने के लिए अगर कुछ प्रॉब्लम हुआ तो पूछ सकते हैं. Anyone?
सर मेरा ज्वाइन नहीं हो रहा था सर. सर थोड़ा सा इसको रिपीट कर दीजिएगा. सर ज्वाइन नहीं हो रहा था उस टाइम से, नेटवर्क का इशू हो रहा था.
अच्छा अच्छा, और बाकी
सर
बाकी
बस
किसी
थोड़ा
को?
सा इंट्रोडक्शन टॉपिक.
देखो, टॉपिक का इंट्रोडक्शन जो है, ये हम लोगों का कोई एल्गोरिदम नहीं है. ठीक है, बेसिकली ये हम लोगों का कोई एल्गोरिदम्स नहीं है, कि जैसे हम लोग अभी तक देखते आ चुके हैं कि हम लोग कोई एल्गोरिदम को सॉल्व कर रहे हैं. कई हम लोग जितने एल्गोरिदम्स हम लोग देख चुके हैं, ऐसे नॉर्मल जो एल्गोरिदम्स हम देख चुके हैं, ये ऐसे टाइप का नहीं है. ये एक रिसर्च पार्ट है. क्या रिसर्च पार्ट है? कि हम लोगों का जितना हम लोग का एल्गोरिदम्स है, कुछ एल्गोरिदम्स हम लोग का पॉलिनोमियल टाइम लेते हैं. जैसे लीनियर सर्च, इसका n है टाइम. बाइनरी सर्च का log n, इंसर्शन सॉर्ट का n स्क्वायर, मार्च सॉर्ट का n log n, मैट्रिक्स मल्टीप्लिकेशन का n क्यूब. और एक्सपोनेंशियल, ऐसे एक्सपोनेंशियल टाइम जो है एल्गोरिदम लेते हैं, वो भी है. अब हम लोग का मोटो क्या है, हम लोग का रिसर्च क्या है अभी, कि हम लोग जो एल्गोरिदम एक्सपोनेंशियल टाइम लेते हैं, उसको हम लोग अगर पॉलिनोमियल टाइम में सॉल्व कर सकते हैं, तो वो हम लोग ट्राई करेंगे. या हम लोगों का जो एल्गोरिदम्स है, सबसे फास्टेस्ट सर्चिंग एल्गोरिथम बाइनरी सर्च जो लॉग टाइम लेते हैं, उसको अगर हम ऑर्डर ऑफ वन में हम लोग अगर कन्वर्ट करें उसको और भी क्विक एफिशिएंटली सॉल्व कर सके, वो हम लोग का रिसर्च करेंगे। अब ये जो रिसर्च है, ये रिसर्च अभी तक फुलफिल नहीं हुआ है, ये रिसर्च चल रहा है, इस टॉपिक के ऊपर रिसर्च चल रहा है, बट इसका बेसिस में हम लोगों का रिसर्च हो रहा है। अब उसमें पार्ट है एक डिटर्मिनिस्टिक। अब इसका अगर हम देखें कि एक्सपोनेंशियल जो टाइम है, एक्सपोनेंशियल टाइम टेकन एल्गोरिथम है। अब हर एक एक करके हर एल्गोरिथम्स को हम लोग अगर सॉल्व करने के पॉलिनोमियल टाइम में, तो मानो कि 100 साल चला जा सकते हैं। ऐसे इजी नहीं है, ऐसे इजी प्रोसेस नहीं है। तो इसके लिए क्या है, हम लोग अगर ये जो चारों या पांच जो एल्गोरिथम्स है मेरा, इसके अंदर अगर रिलेशनशिप शो कर पाए कि ये इसका रिलेशन ये ऐसे रिलेशंस में है, और इसको हम लोग कलेक्टिवली अगर एफर्ट दे के एक ही को हम लोग रिलेशन बिटवीन देम को शो कर सकते हैं, तब हम लोग क्या है कि एक प्रॉब्लम को सॉल्व करेंगे, जिससे हम लोग कंक्लूजन निकाल के बता सकते हैं कि ये प्रॉब्लम ऐसे सॉल्व हुआ तो बाकी प्रॉब्लम भी ऐसे सॉल्व होगा मेरा। तो ये होगा हम लोग का रिसर्च बेस्ड। ओके। और डिटर्मिनिस्टिक और नॉन डिटर्मिनिस्टिक पार्ट, डिटर्मिनिस्टिक पार्ट में हम लोग जानते हैं एल्गोरिदम को कि कैसे हम लोग सॉल्व कर सकते हैं। नॉन डिटर्मिनिस्टिक में हम लोग नहीं जानते हैं उसको कैसे सॉल्व कर सकते हैं। तो ऐसे ही जो एग्जांपल दिखा है कि हम लोग अगर चाह रहे हैं कि डायरेक्टली हम लोग का रिटर्न कर दे डायरेक्टली, ऐसे तो कोई एल्गोरिदम अभी तक नहीं निकाले हम लोग, नहीं है। तो वो हो गया मेरा नॉन डिटर्मिनिस्टिक पार्ट। ठीक है, क्लियर?
यस सर।
ओके। यही देखोगे, नोट्स पढ़ोगे तो और भी तुम्हारा टोटल ये है, ये कोई एल्गोरिदम्स नहीं है, इसीलिए ये जगह में थोड़ा अच्छे से समझ के ये पढ़ना। ओके, सो
यस
देन
सर।
थैंक यू एवरीवन।